Sorry, I just accidentally uh, stopped the recording videos, but over here you have the function is 3 times x. So now you can find the work. The work is the integration from 0 to 5 because initially your spring is as the rest status and you take it 5 feet beyond its natural length. So that means you have to move an object from 0 to 5 feet. Okay, and then the forcing function is 3x at dx. The integration of this thing is 3x squared divided by 2. Then you plug in the upper bound and lower bound. When you plug in 0, you just have 0. If you have 5, then you have 3 times 5 squared, which is 75. Okay, 75 divided by 2. So this is the amount of work, and the unit for the work is feet pound. Okay, feet pound. Feet pound. Okay, in the next problems, the question again, you have some spring system, okay, and the thing is you don't have the question want you to find the work to stretch out the springs from 1 meters to 1.2 meters. But the point is, if you want to do that, you have to know the general formulation for your spring force. And if you want to get the formulations for the spring force, you have to know the spring constant. So the question gives you some information to help you find the spring constant. Okay, so initially, the question said that the natural length of the spring is 1 meters. Okay, the natural length of the spring is 1 meters, and you spread it out just a little bit. You spread it out just 0.01 meters. Okay, you just spread it out just a little bit. Okay, this you just spread out 1.1 meters because you increase the length from 1 to 1.01. So that means that the amount of length you have spread out is just 0.01 meters. Okay, and the question said that the spring required 20 June to do that. So that means, let me suppose that the spring force is K times X, okay? And the point is, you have that to stretch the spring out 0.01 meters. That means you have the work you need to do is the integration from 0 to point is the integration from 1 to 1.01. Okay, and the spring force that the spring force is kx. Okay, and the question saying that the amount of work required to stretch the spring 0.01 meters is 20 June. 20 June. Okay, so from here you have that. I think you should put 0 to 0.01. Okay, 0.01. Okay, because the natural length, I would say that the natural length should be set up as 0. So you have 0 and you shred it out 1.01 meters. Okay, so the work required to do is from 0 to 0.01. Okay, so from here, I believe that you have kx squared divided by 2. You have 0 and 0.01 equal to 20. So based on this information, I believe you can figure out the values for k. So over here, I will plug in the upper bound and the lower bound. I have 0.0, I have k times 0.01 squared divided by 2 equal to, okay, so firstly, let me finish my integration. Okay, Let me finish my integration. 0.01 square give me 0.001 divided by 2. Okay. You have 1 over 100. You square it, so you have 1 over, you have 1 over 0. Sorry, you should have 1 over 0. 1. Okay. And then you divide by 2, so you have 0.00005K. Okay, so this is the amount of work you need to do if you want to stretch out the spring 0.01 meters from its natural length. Okay, and the question said that amount work equal to 20 Joule. Okay, therefore I have 20 equal to 0.00005K, and from here I can compute the exact values for K. So K should be let me use my calculators. So 20 divided by 0.0005, I will have 20 divided by point 0.0005. I have 400,000. This is a little bit large, but I think it's okay. Okay, and now the questions want you to find the amount of work you need to do, you need to spend if you want to stretch out the spring 0.02 meters from its natural length. Okay, so from here, after you get the values for the spring constant, you can generate the function for the spring force, which is 400,000 times k. I'm sorry, times x. Okay, I mean the general function for the spring force is k times x, where k is the spring constant, and from the informations of the question, you have figured out the values for the spring constant is 400,000. Okay, so therefore the spring force is 400,000 times x, and now the question wants you to find the work you need to do if you want to stretch the spring from 1 meter to 0.02 meters. That means you need to stretch out 0.02 meters beyond from its natural length. Okay. Therefore, I will have the integration from 0 to 0.02 of 400,000 x dx. Okay. I can take 400,000 outside. I just have the integrations of x, and the integration of x is x squared divided by 2. And then I plug in the upper bound and lower bound. Okay, so I have 400,000 multiplied with 0.02 square divided by 2. So I have 200,000 because 400,000 divided by 2 give me 200,000. And 0.02 square give me 0.0004. So I will have 4. Okay, 200,000 times 104 give me 80. Okay, so 80 Joule. Okay. Okay, in the next questions, want you to find the work that is required to wind up hanging cables of length 100 feet with the weight density 3 pound per foot. So the ideas of the question is you can think in the way that you are standing in the top of the building, okay, and there is some cable that is 100 feet long, okay. There's some cable that is 100 feet long, okay, and the question wants you to find the amount of work you need to spend if you want to take the entire thing to the top of the building, okay. So you can think in this way. It means every little piece of this cable has to travel into the top of the buildings, but the the for each of the little pieces, the distance they travel will different. This one just need to travel a little bit. This piece over here just need to travel a little bit more. This little piece had to travel a little bit more. I mean, and the last piece has to be travel the furthest one. So the thing is, you can think in this way. You can think this is the you can think this is the axis. Okay, and the cable is 100 feet long. Okay, the cable is 100 feet long. Okay, so let me consider the piece of cable as the position x. Okay, let me consider the cables as the piece of cable as the position xi. Okay, so if you want to take this thing up to the top of the building, that means this thing has to travel a distance of 100 minus xi. Okay, so that means if you want to find the if you want to find the length of if you want to find the work, you just need to set up the integration from 0 to 100. Okay, and the thing is you need to take the density multiply with the distance it has to travel, which is 100 minus x. Okay, this is the force. Okay, and you need to take the force multiply with the distance it has to travel. Again, for the piece abroad that the position xi, it has to travel the distance 100 minus x. So this is the amount of work if you want, and you have to do the same things for every little piece of the rod that you have. Okay, if you want to take all the thing up to the top of the building. Okay, so that you have to repeat the same. Like again, if you have to work with this little piece, this thing has to travel 100 minus x I. Okay, so the work you have is 300 x minus 3x squared divided by, sorry, you can take 3 outside. Okay, you just focus on the integrations 1 minus x dx, and I believe this thing is not a big problem. The integration is 100 the integration of x is x squared divided by 2, and then you just need to plug in 100 and 0. Sorry, it should be 100x. Okay, you have 3 over here. If you plug in 0, it's not a big problem. If you plug in 100, what you're gonna have? You're gonna have 100 times 100 minus 100 squared divided by 2. So at the end, you will have 3 times 10,000 minus 5,000. So you have 5,000 divided by 3. Okay, and the unit is feet pound. Okay, feet pound. Okay, in this in the next question, okay, in the next question, the questions want you to find the work is required to pump out all of the waters out of the cylindrical tank. Okay, you have the cylindrical tank, and the cylindrical tank is full of water, and the questions want us to find the amount of work is required to pump out all of the water out of the tank, to pump the water out of the tank. Okay, so we're gonna use the ideas of discretization. Okay, so the thing is, I mean, for the waters on the top of the tank, you don't have to spend a lot of work because it is on it is on the top of the tank, so it you can take the waters on the top out of the tank really easily. But for the layers for the waters for the layers of waters in the middles of the tank, it had to travel some distance to get out of the tank. For the waters at the bottom of the tank, it has to travel the further distance to get out of the tank. Okay, so you have to develop the general formulation to work with every single layer of the tank if you want to take them out of the tank. Okay, so over here I would use the ideas of discretization. So let me assume that the thickness of the layers is dx. Okay, so you need to find the mass of the tank. Okay, you need to find the force that need to lift this thing up. Okay, to pump out this thing out of the tank, you need to find the force, and then you need to take the force multiply with the distance it has to travel. Okay, so over here, uh, I need to find the volume. Okay, the question is saying that for each a feet cube, the water is 62 pound. Okay, for each feet cube, the water is 62 pound. So I need to find the volumes of each of these layers, and then I would take the volumes multiply with the density to get the mass for the tank. Okay, so how can we find a volume? The volume for the layers, the volumes is the areas of the base multiply with the height of the layers. Okay, and the this we are working with the cylindrical tank. So the base is just a circle, and this is the circle separated as 5. So I have 5 squared times pi. The height of this layers is just the thickness of my discretization. So I have dx. So I have 25 pi dx. Okay, and the question's giving us that the densities of waters is 62 pounds per feet cube. So that means for each feet cube, for 1 feet cube, it will weigh 62 pounds. And now you have 25 pi dx feet cube. You have 25 pi dx feet cube. So if you want to find the mass of this thing, you just need to you just need to take 20 pi dx multiply with 62 pound. Okay, so the mass of water, okay, is 25 pi dx times 62. Okay, 25 times 62 give you 1550 pi dx. Okay, so again, I want to explain this again. The question saying that the densities of water is 62 pound per feet cube. So for each unit of volume, it's gonna weigh 62 pound. And now you have this amount of volume. So if you want to find a way, you just need to take 20 pi dx times 62. So this is the way for each layers of waters. Okay, and because the unit that you have is pound, it is also the amount of force that you need to do. So I'm sorry, force. If the unit is pound, then mass is also the force, and you have 1550 pi dx pound. Okay. Okay. So now you have no the force that you need that is required you if you want to lift these layers of water vertically and out of the tank. The next thing you need to do is you have to find the distance that these layers had to travel to get out of the tank. So let me assume that this layer is at position xi. Okay. Let me assume that this layer is at position xi. Okay. You will start from zero. I mean, the bottom layers will have zero. Okay, x equal to zero. The layers of water that is at the top will be equal to x equal to 20. We'll have x equal to 20. Okay, let me explain again. The layers at the bottom of the tank will have the position x equal to zero. The the layers at the top of the bottom at the top of the tanks will have the position x equal to 20 feet because the height of the entire cylindrical tank is 20 feet. So let me work with the general layers of water that at the xi position. So for the layers at the xi position, it has to travel 20 minus xi feet to get out of the tank. Okay, so the work that requires you to lift the layers out of the tanks is 100 pi dx times 20 minus x. Okay, this is the work you need to lift each of the layers. And because you need to move all of the layers of waters out of the tank, so that means you have to repeat the process for every single layers at the x position. Okay, that means you have to start from 0 to 20. So you're gonna take the work from all of the layers for all of the layers. That means you have to start from 0 to 20. Okay, so I will take the integral from 0 to 20 of 1550 pi times 20 minus x dx. Okay, and then you're gonna have uh, you're gonna have let me take 1550 pi outside because it's just constant. So you take the integration of 20 minus x dx. Okay, so you're gonna have 20x minus x squared divided by 2. Okay, multiply with 1550 pi. And you plug in the lower bound and the upper bound, you're gonna have 550 pi. 200 times 200 gives you 4. I'm sorry, 20 times 20 gives you 400. 20 squared divided by 2 gives you 400 divided by 2. So that means you have 155 pi times 200 because 400 divided by 2 is 200. 400 minus 200 gives you 200. And then you multiply, you will get the final result, and the unit is uh, feet pound. Okay, feet pound. Okay, so this is how you um, find the work that is required to pump all of the water out of the tank. Okay. And again, you're gonna use the ideas of discretization because you have to understand that for the waters on the top of the tank, it's really easy to get out of the tank. Okay, you don't have to use a lot of force to take it out. But for the layers at in the bottom of the tank or in the middle of the tank, it had to travel some distance to get out of the tank. So you have to use the ideas of discretization. You have to develop the general formulation for the layer at the xi position. Okay, the work that's required to lift the layers of water at the xi position out of the tank, and then you're gonna sum them up because you need to take all of the water. So your integration from will go from 0 to 20. Okay. Okay, so let's go to question 14, the last problems on the work. Okay, so in this problem, the question is saying that the Great Pyramid of Giza has a height roughly 450 feet, okay, and it had a square base. It had a square base, which is 550 times 550. The question wants you to find the cross-sectional areas A at the height H, okay, at the height H. Okay, so you have some cross-sectional H over here. And the question is saying that if the rock used to build the pyramid weigh approximately 100 pounds per unit feet cube, then how much work did it take to lift all of the rock and to build the Great Pyramid of Giza? Okay, so first let's solve the first part of the problem. What is the cross-sectional areas A as the height H? Okay, so we have that this is a little bit tricky. Okay, so let me consider the red square over here as the cross-sectional at the height H. Okay, and I want to find the areas of this red square. Okay, so if you want to find the area, you have to know the sign. Okay, you have to know the sign. And the thing is, you have to connect the sign of this red square with the sign of your pyramid of Giza. Okay, so the only way to find the relations between them is I'm gonna draw the right triangle. Okay, I'm gonna draw the right triangle which contain the half side of the red square and the half side of the base. Okay, so over here, let me work things in two dimensions. I have the right triangle. I have the right triangle OI2K. Sorry, this is my right triangle, the right triangle OI2K. Okay, I take out this right triangle. Okay, and let me consider the sign I1H. Okay, the thing is, I want to find the areas for the red square over here. So I need to know I2H. If I know I2H, I'm gonna double it to get the sign for the red square. Okay. I1 is the centers of the red square. I2 is the centers of the base. Okay. And again, I want to know the areas for the red square. So if I am if I know the sign for I2H, I just need to double it to get the sign for the red square. Okay, the point is over here. We know that OI2 is 450. Okay, OI2 is 450. So this one is 450. Okay, OI2 is 450. This is the height of the pyramid. We also know that I1, I2 is H. Okay, I1, I2 is H. Okay, and I2K is half of the sine for the square at the base. So it should be 375. Okay, and now I want to focus on computing I1H. So based on the similar triangle, okay, based on a similar triangle, I have that. Firstly, OI1 should be 450 minus H. Okay, this is OI1. And from the similar triangle, I have that OI1 divided by OI2, sorry, OI1 divided by I1H equal to OI2 divided by I2K. Okay, this side divided by this side equal to this side divided by this side because of the similar triangle. And OI1 is minus H divided by I2H, okay, sorry, I2H, and OI2, OI2 is 450, I2K is 375. Okay, so let's simplify this thing. We're gonna have I1H equal to, okay, so what is 450 divided by 375? Okay, let me compute it. 450 divided by 375. You have 6 over 5. Okay, you have 6 over 5. And from here, you have that I1H is 450 minus H times 5 over 6. Okay, you cross multiply this thing to the right hand side, you cross multiply 5 to the left hand side, and you divide it by 6. Then I1H is 450 minus H times 5 over 6. Okay, and then I1H, then the sign of the red square will be the double of I1H. So A prime P primes will be 2 times I1H. You're going to have 2 times 4 minus H times 5 over 6. You have 5 over 3, 450 minus H. Okay. And because you want to find the the areas of the red square over here, the square at the height H, then and you know the sign of that square. You just need to square it to get the areas for the red square. So the area is a prime b prime square. Then you have 5/3 times 450 minus h square. Then you have 25/9 times 400 minus h square. Okay. Okay, so now let's compute the work that we need to lift all the rock, and then we can build the pyramid. Okay, again, you have to use the ideas of discretization. Okay, you have a bunch of layer rock. Okay, you have a bunch of layer of rock. Okay, and because you want to build the pyramids of Giza. Okay, then you will stack layers of rock over layer of rocks. Okay, you're gonna stack them. Okay, you're gonna stack the bunch of layers. Like firstly, you have to build a base. Okay, you have to build a base, and then you're gonna stack another layers of rocks on the top of that, and you keep doing that. Okay, uh, for the last layer, it doesn't have to. You don't have to move it a lot, but as you move further, and you keep going further upward, and you keep moving upward, right? You have to move the layer of the rock in the much harder distance, in the longer distance, to put them on the top of the other layers. Okay, so that means each layer of rocks will have different distance to travel along the way when you build the pyramid of Giza. Okay, so that means you need to find the amount of work corresponding to each layer of the rock. Okay, and to find the work for each layer of the rock, you have to find the force. Okay, and you take the force multiplied with the distance. Okay, you need to find the work for each layer of the rock, and to do that, you have to find the force you need to move each of the layers, multiply with the distance that layers has to travel. Okay, so how can we find the force? The force is given by mass times, sorry, the force is given by the mass times the density. Sorry, the force is the mass. Okay, the force is the mass because over here you are working with the unit pound. So the force is just the mass. Okay, and how you can find the mass? The mass is the volume multiplied with the density function, with the density constant. Sorry. Over here, uh, the question saying that for each feet cube, the rock is weighted 150 pounds. Okay, so if you want to find the mass for each layer of the rock, you just need to find the volumes of that layers, and then you multiply with this constant. You're gonna get the mass for the layers of the rock. Okay, so how can you find the volume? So let me consider the layers of the rock at the xi position. Okay, as the random height positions h. Okay, we know that the you have the layer of the rock. It's just a rectangular box. Okay, it's just rectangular box. So to find the volumes for this rectangular box, you just need to take the area of the base multiply with the height. The height is just the thickness of your discretization. So this is delta x. The area of the base for any random layers of the rock is given by this formulation, the question that you have done in part A. So from here, the volumes of the rocks, the volume for layers of rock is the areas of the base multiplied with the height of layers. Okay, the area of the base is determined by the formulation that you obtain from the part one, the cross-sectional areas of the red square at the height h. So I have 25 over 9 times 400 minus h squared. Okay, the height of the rocks, the thickness of the rocks. Okay, let me just run the thickness. Okay, the thickness. You want to find the volumes for the layers of the rocks. Okay, you want to find the volume for the layers of the rocks. So you need to take the area of the base multiplied with the thickness, and the thickness is just the length of your discretization, which is delta x or dx. Okay, and once you guess the volume, when you guess the volumes, you just need to take the volume multiplied with the densities. You're gonna have the mass or the force. Okay, the force will be the volumes multiplied by the density constant. Okay, let's simplify this calculation. 25 over 9 times 150, you have 1250 divided by 3 times 4 minus h squared. Okay, so this is the force that is required to lift up any layers of the rocks. Okay, and now you want to find the work that is required to build that layers. That means you have to find the distance that that layer has to travel. Okay, so for the bottom layers, for the bottom layer, it doesn't have to travel much, so it's just zero. But for the layers of rock that at the high position h, that means it had to travel upward h to get into the top of the other layers. So that means the work that you need to do is you take 100, you take the force that is required to lift the rocks, multiply with the distance it had to travel. Okay, for the layers of the rock at the position h, it just needs to travel h. It needs to travel. It has to travel upward each feet to get into the top of the other layers. Okay, and now you're gonna some. This is the force. This is the work required for each layers, and because you want to find the amount of work that is needed to complete building to complete to complete build the entire period of Giza, then you should consider the integration from 0 to 450 of these things. So you have 15023. It should be the h. Okay. um, DH, DH, DH. Okay, 400 minus H square times HDH. Okay, I take out the constant. Okay, I have 450 minus H square times HDH. Okay, we have this integration. So let me compute this integration with my calculator. So 0 to 450, 450 minus H square times H. I mean, to finish this integration is not a big problem because you just need to expand the square, you distribute the H into the parentheses, and then you use the power rule to find the entire derivative. So after you get this thing done, you're gonna have 1250 divided by 3 times 3417187,500. Okay, and you simplify this calculation, you have some numbers, and that is fifth power. Okay, fifth power. So this is how you compute the work that is required to lift up the rock and build the Giza of to build the pyramid of Giza. It should be a super large numbers over here. Okay, so that means to build the great pyramid of Giza, it require a lot of work. Okay, so it's kind of interesting how the people in the past has built this thing. Okay, without the help of without help of some tools like we have in the present. Okay, so we have complete the videos on mass, force, and work. And in the next videos, we're going to continue with the central topics.